Hey guys, Miss Miklos here, and we're going to do things a little bit out of order on the review worksheet. This is our pre-calc chapter 7 review, and I wanted to start with our calculator, so I wanted to start with intersect. So if you guys look at your review worksheet, this is like section 2, I guess, and we're going to do number 1. The nice thing about number 1 is y is already isolated. So remember, if y is not by itself, that would have to be my first step. So I'm going to go ahead and type in these functions. So I have 2x squared minus 4x plus 1. Okay, and then I'm going to press my down arrow and I'm going to type in x squared minus 4x plus 3. Okay, and if we notice here, both of these are highlighted, which means that it's going to go ahead and graph both of them. So I'm pressing zoom 6, and I know that these should both be parabolas. There's our first one, and there's our second one. So it definitely looks to me like it intersects in two places, one over here and one somewhere over here. Okay, and I'm not quite sure where, and that's okay. So I'm going to press second, trace, and that gets me to my calculate menu. And remember, we want option 5, which is intersect. So I'm going to type in 5. And right away it asks me, is this the first curve? And this is the equation that it's giving me. Since I only have two functions, I know that that has to be one of my two curves, so I'm going to press enter. Now it's asked me, is this your second curve? And your calculator is actually smart here where it jumps to that other equation, so I'm going to press enter again. And I can see that there is a point of intersection over here, so I'm actually going to move to the left a little bit and press enter. And it tells me that my point of intersection is negative 1.414, 10.657. Now, technically, that's up here. That is off of our screen, but that's okay. I can still write down this ordered pair. And if I wanted to go ahead and change my window, remember I can press window. And I'm going to change the Y max to, let's say, 15 and press graph. And this might actually show us a better picture. And it's still kind of tough to see, but it does intersect up here somewhere. Now, I know it should only touch once. Okay, so we found this point of intersection. Now I'm going to find this point of intersection. So I'm going to press second, calculate again, intersect. And it's going to say, is this the first curve? And we're pressing enter. Is this the second curve? We're pressing enter again. And now I'm using my right arrow and I'm moving closer to where I think the point of intersection is, which is going to be my guess. And I'm going to press enter a third time. And it tells me this point of intersection is 1.414, negative 0.657. Okay, so key things when I graph it, we might need to change our window slightly just to see all the points of intersection. I'm pressing second, trace, and I'll even do that again, and choosing option 5, which is intersect. From there, I'm just answering those 3 questions, first curve, second curve, guess, and it should give me my ordered pair. Okay, so now we're going to go ahead and we are going to solve by substitution. I'm going to do number 2 here, and we talked briefly in class that normally if I have one variable that's squared, sometimes it makes the job easier if I isolate my non-squared variable in the other equation. So I need to get y by itself here, which means that I'm going to add 2x, so I'm going to get y equals 5 plus 2x. And that means that in my other equation, wherever there's a y, I'm substituting in 5 plus 2x. I need to then distribute that negative. So I have minus 5 minus 2x equals 1. And I notice that this is quadratic. So I'm going to want to get it set equal to 0. So I'm also going to subtract this 1 over to make this negative 6. We know a lot of different methods to solve quadratic equations. Factoring, completing the square, quadratic formula, square rooting. In this case, factoring would be the easiest method. And I have to think what factors of negative 6 add up to be 1. And that would be positive 3 and negative 2. So I'm going to set both of these factors equal to 0. So I get x equals -3 and x equals 2. Now, I know I'm not done yet. This just tells me that 2 ordered pairs are going to be solutions to this, because that's telling me that this is like a parabola with a linear equation going straight through it, which we could see sometimes means that we have 2 points of intersection. So when x is equal to -3, y is 5 plus 2 times -3, or -1. So -3, -1 is one of my solutions. And once again, I would want to check it in here. 6 minus 1 is 5. 9 minus 9 plus 1 is 1. So that does work. I also need to see what is our y value when x is 2. And I would get y equals 5 plus 2 times 2. So y is equal to 9. So 2, 9 is my other ordered pair. And let's check that. -4 plus 9 is 5. 4 plus 6 is 10, minus 9 is 1. So these would be our 2 solutions using substitution. So just to recap, in substitution, I am isolating a variable in one equation and substituting the expression it's equal to into my other equation so that I only have either x or y to deal with. Once I get what that value is, I can back substitute into an equation to solve for the other part of our ordered pair. We started this video talking about intersections, so I skipped that section, and now we're looking at elimination. And I'm going to go ahead and look at number 2 here. In elimination, remember, my goal is to either cancel out the x's or the y's. So we really have a choice here. I'm going to try and cancel out the x's here. So that means that I would need my x coefficient to be the opposite of -2. So I'm going to multiply everything by 2. So I get 2x plus 2y equals 12. And something really strange happens here. My variables cancel out and I get 0 equals 0. And in class we said when our variables cancel out, we need to ask ourselves, is this equation true? Is 0 equal to 0? And if we thought the answer was no, that meant that those lines never intersected, which means that we have no solution. If we say yes, it is true, that means it's the same line and there are an infinite number of solutions. And in this case, yes, 0 is equal to 0. So the way that we write that is all the ordered pairs on the line, and then I can write either of those two equations. Since they're the same equation, it doesn't matter which one I choose to use. So what this is telling me is that every ordered pair on this line is a solution to this particular system. So elimination, I'm trying to eliminate either my x or my y by adding them together. So I want to make sure that either my x or my y coefficients are opposites. Okay, the next problem I want to go through is a Gauss-Jordan elimination problem. So I'm going to go ahead and just go through number 1 here on section 5. So with Gauss-Jordan, the first thing that I want to do is set up my augmented matrix. Remember, my first column are the x coefficients, my second column are the y coefficients, and my third column are our constants. We want to get the left side of this matrix to be our goal matrix, which we now know is the identity, which is 1, 0, 0, 1. And we learned that there are really 3 things we can do. We can either switch 2 rows, we can multiply a row by a constant, or we can add a multiple of one row to another row. In this case, or really in any problem, I always want to start with the first column, then move on to the second column. In each column, I want to get the 1 first. So looking at this, I need to think, how can I make a 4 into a 1? And the way that I'm going to do that is by multiplying by 1/4. The significance of 1/4 is that it is the reciprocal of 4. When I multiply row 1 by 1/4, I get 1, -1/4, and 1/4. Now I want to turn this 8 into a 0, so I'm thinking if I added -8 to 8, that would help me out. So I'm going to do -8 times row 1. There we go. Times row 1, which would give me -8, +2, -2. Okay, so I'm doing -8 row 1 plus row 2. So -8 plus 8 is 0. 2 plus 1 is 3. -2 plus 17 is 15. So we have successfully gotten our first column. Now we're moving to the second column. I want to transform this 3 into a 1, and I'm thinking that we can do that by multiplying by 1/3. Once again, I'm noticing whenever I want to get a 1, most of the time we are going to multiply by the reciprocal. When I distribute this value, I get 0, 1, and 5. Next, I need to think, what could I add to 1/4 to make it be 0? And I'm thinking we are going to do 1/4 times row 2 plus row 1. So 1/4 times row 2 would be 0, 1/4, 5/4. So I have 0 plus 0 plus 1 is 1. 1/4 minus 1/4 is 0. 5/4 plus 1/4 is 6/4, or 3/2. So based on this, our ordered pair is 3/2, 5. And I definitely would want to double check this answer, so let's do this. 4 times 3/2 is 6. 6 minus 5 is 1, so it works. 8 times 3/2 is 12. 12 plus 5 is 17, so that makes a true statement, which tells us 3/2, 5 would be our answer. The next problem we're going to go through is solving by using the inverse method. And the way that we're going to see this on the test, I'm actually going to give you the inverse already. Okay, there's going to be different problems, though, where we need to find an inverse. So just to review, the way that we're going to find an inverse, we have two different ways. In this problem, I'm going to use the method that you guys used the most on your last quiz. So this is our original matrix. To find the inverse, okay, I know it's going to be 1 over the value of the determinant times, we switch our A and our D value. Okay, so I get -5 and 3. And then these values become the opposite. So 4 becomes -4. -4 becomes +4. And to figure out what goes in the denominator here, I'm going to have to find the value of the determinant. So I'm going to do -15, and then Mr. Determinfish says, subtract, baby. -4 times 4 is -16, so I get 1. So that tells us our inverse is -5, -4, 4, 3, because we just had to distribute a 1 to each term. So I know that the inverse times B is our constant matrix, is going to give us the values of x and y. So we're going to go ahead and do -5, -4, 4, 3 times 2, 3, and that's going to give us x and y. So to find out what x is, I'm going to go ahead and do row 1 times column 1. And I'm going to go ahead and circle this row 1, column 1. So I have -5 times 2 plus 4 times 3. -10 plus 12 is 2. Next, we need to find our y value. So I'm going to do row 2 times column 1, -4 times 2, plus 3 times 3. -8 plus 9 is 1. So that is telling me that our ordered pair here is 2, 1. And let's double check. 6 minus 4 is 2. 8 minus 5 is 3. So the big deal here, remember, on this problem, I'm actually going to give you this to start off with. We just need to remember, it is the inverse times our coefficients, and that's giving me my x and my y value. Next, we're looking at Kramer's rule. So we're going to go ahead and do number 1. So the first thing I need to find is determinant D. I know my first column are my x coefficients. My second column are my y coefficients. So now we're going to go ahead and I'm going to do 36 minus, because Mr. Determinfish says subtract, baby, negative 18. So when I add those together, I get 54. Remember, if my D value ends up being 0, that means that I need to go back and solve the system using a different method, because that either means that they are the same line or they're parallel. So now we're going to go ahead and find D sub x. Okay, we learned whichever variable is here, that is the column I'm replacing with the constants. So D sub x is going to be negative 10, 12, negative 3, 9. So if we're going through this, I get negative 90. Mr. Determinfish says subtract, baby, negative 36. So I get negative 90 minus negative 36, which is negative 54. Lastly here, we're going to find D sub y. This time, since I have y here, that means I'm replacing my y column with my constants, which are negative 10 and 12. So I have 4, 6, negative 10, 12. When I start in the top left-hand corner, 4 times 12 is 48. Mr. Determinfish says subtract, baby. Negative 10 times 6 is negative 60. So I end up getting 108. Now, I know to actually find my x value, it's going to be D sub x divided by D. To find my y value, it's going to be D sub y divided by D. So x is going to go ahead and be negative 54 over 54, and y is going to be 108 over 54, which gives us an ordered pair of negative 1, 2. And let's double check this. Negative 4 minus 6 is negative 10. Negative 6 plus 18 is 12. So negative 1, 2 is our solution. Now, let's go through part of the 3 by 3 here just so I can kind of demonstrate. Our D determinant, this time, my first column is x's still. My second column is still y's. Notice I have a 0 here because I don't have a y value in that third equation. What makes this one different is we have z's, so my third column are now z's. I know that I need to rewrite my first 2 columns again. And now we're going to start in the top left-hand corner. 1 times 2 times 5 gives me 10. 2 times negative 2 times 1 is negative 4. 1 times negative 4 times 0 is 0. Now Mr. Determinfish says subtract, baby. 2 times negative 4 times 5 is negative 40. 1 times negative 2 times 0 is 0. 1 times 2 times 1 is 2. So I have 6 minus negative 38, which is 44. Okay, so that is our D value. Now to find each value for x, y, and z, I'm going to have to find that particular determinant and divide by 44. And just to save some time here, I'm just going to demonstrate how to find D sub x. Okay, and then I think we can kind of follow along from there. For D sub x, that means that I'm replacing my x column with my constants. My second column is still 2, 2, 0. My third column is still 1, negative 2, 5. My next 2 columns, I'm going to repeat those first 2 columns again and rewrite them. Now let's go. 8 times 2 times 5 is 80. 2 times negative 2 times 8 is negative 32. and then I get 0. Mr. Determinfish tells us to subtract, and working backwards now, I get negative 100, 0, and 16. So I have 48 minus negative 84, which when I combine those ends up being negative 132. So if I want to find x, once again I'm doing d sub x divided by d, so I have negative 132 divided by 44, which gives me negative 3. So negative 3 would be the x value of my ordered triple. I would need to repeat this process with my y's and then again with my z's in order to find this ordered triple altogether. Then to double check my answer, it needs to make true statements in all 3 of these equations. So now we're done with the solving equations portion, and we're going to go on to part 2 of the review. And we're going to start with partial fraction decomposition, and I'm going to look at number 1 here. The first thing I need to do with partial fraction decomposition is factor this. So I need to think what factors of 8 add up to be 6. And it's going to be plus 4 and plus 2. So what I'm going to do now, I'm going to write this as a over x plus 4 plus b over x plus 2. So notice I wrote the same 2 factors. I don't know what their numerators are going to be, so that's what I put as a and b. I'm now going to multiply everything by the LCD, which is x plus 4 times x plus 2. When I distribute to this first term, I notice these are going to cancel out, so I'm simply left with 4 minus x. When I distribute to the second term, the x plus 4's cancel out, so I'm left with a times x plus 2. When I distribute to this third term, the x plus 2's are going to cancel out, so I'm left with plus b times x plus 4. So I have 4 minus x equals ax plus 2a plus bx plus 4b. And I notice that even though none of these are like terms, some of them have x's and some of them don't. So I'm going to go ahead and group them. So my x values are together and my non-x values are together. In fact, I could write this as a plus b times x plus 2a plus 4b. Now, to be honest, we really don't care about the value of x. We care about the values of a and b. And what this has done for us is I know that if these 2 expressions are equal to each other, that this x coefficient has to be equal to this x coefficient, and this constant has to be equal to this constant. So I'm going to go ahead and write these 2 equations. I'm going to write negative 1 equals a plus b, and 4 equals 2a plus 4b, because I'm setting 4, which is the constant, equal to this constant, and I'm setting negative 1, which is the x coefficient, equal to a plus b, which is that x coefficient. So now we have a 2 by 2 system to solve, and I'm going to use elimination. So I'm going to multiply this by negative 2, and I get 2 equals negative 2a minus 2b. My other equation stays the same. So when I combine these together, I get 6. Notice my a's eliminate each other, equals 2b, or 3 is equal to b. Now when I substitute that into my other equation, I get negative 4 equals a. So what we just found for a and b here were the 2 coefficients, the 2 numerators of the fractions we were trying to find. So my answer is negative 4 over x plus 4 plus 3 over x plus 2. So now we're looking at operations with matrices, and we're going to focus on number 1 here. So the first thing it says to do a plus b. Okay, so I'm going to go ahead and do that. First of all, we know in order to add matrices, we need to have the same dimensions. Okay, this matrix is a 2 by 2. This one is also a 2 by 2. Remember, it is always row by column. So we have 2 rows, 2 columns. When we're adding and subtracting, we just combine the similar entries, so the corresponding entries. So in this case, 7 plus 10 is 17. Negative 1 plus 14 is 13. 3 plus negative 20 is negative 17. 5 plus negative 3 is 2. Okay, subtracting, we would do this same exact thing. Okay, I'm going to go ahead and focus on C. C tells us to do 2 times A. And what this means when I'm doing a scalar value times a matrix, I'm distributing that 2 to everything. So I end up getting 14, negative 2, 6, and 10. Okay, so now we're going to go ahead and work on multiplying. Okay, for number 3, we have a 2 by 2 and a 2 by 2. Remember, in order to figure out if we can multiply, these inside numbers need to be the same. The outside numbers tell me the dimensions of my new matrix. Since these are the same, we can multiply. Remember that matrix multiplication is not commutative, so we're going to go ahead and do A, B first. And this is the only one we're going to do. You guys should get the hang after this. Okay, A sub 1, 1. Remember, this means row 1, column 1. So it would be this top left-hand corner. A sub 1, 1 means I'm multiplying row 1 times column 1. So I have 1 times 2 plus 2 times 0, which is 2. A sub 1, 2 is row 1, column 2, which means I'm multiplying row 1 in our first matrix times column 2 of our second matrix. So I have 1 times negative 1 plus 2 times negative 3. So negative 1 plus negative 6 is negative 7. A sub 2, 1 means row 2, column 1. Okay, so it's row 2, column 1 is this bottom left-hand corner. So I'm doing 4 times 2 plus 2 times 0, which is 8. Lastly, A sub 2, 2 means row 2, column 2. So I have 4 times negative 1 plus 2 times negative 3. Negative 4 plus negative 6 is negative 10. So this would be our answer. If we did B times A, I would have to switch the order of these, and then I would still do the rows in B and the columns in A. If I'm doing A squared, that means I need to actually write out A times A. I'm not just squaring each entry. Okay, let's find the inverse of the matrix. Once again, we already kind of talked about how one way we can find the inverse is by doing 1 over the determinant times, I'm going to switch A and D, so it's going to become 2 and 1. I'm taking the opposites of these other values, so negative 4 and negative 2. Our determinant would be 2 minus 8, which is negative 6. So I'm going to have to distribute a negative 1/6 to each of these terms, so I would get our inverse is negative 1/3, negative 2/3, positive 2/3, because a negative times a negative would be positive. And then negative 1/6 times negative 2 would be positive 1/3, and then negative 1/6. If I really wanted to check if this was accurate, I know any matrix times its inverse should give us the identity, which is 1, 0, 0, 1. Now I want to go ahead and do this same problem using the other method that we learned. So the other method we learned is we put our matrix on the left and our identity on the right. And my goal is to transform the left into the identity. And we actually are off to a good start because my first column is already what we want. It already has a 1. So I need to make this 4 into a 0, so I'm going to do negative 4 row 1 plus row 2. Okay, negative 4 row 1 would give me -4, -8, -4, 0. So -4 plus 4 is 0. -8 plus 2 is -6. -4 plus 0 is -4. 0 plus 1 is 1. Okay, so now moving on, I need to change this -6 into a positive 1. So I'm going to do negative, it might help if I had a pen there, -1/6 times row 2. So I would get 0, 1, sorry, I didn't mean to make that blurry there. Okay, so we get 0, 1. When I do -1/6 times -4, I get positive 2/3 and -1/6. Lastly, I need to change this 2 into a 0, so I'm going to do -2 times row 2 plus row 1. -2 times row 2 is 0, -2, -4/3, and then positive 2 over 6 or 1 over 3. 0 plus 1 is 1. -2 plus 2 is 0. -4/3 plus 1 is -1/3. 1/3 plus 0 is positive 1/3. So that tells us -1/3, 2/3, 1/3, -1/6 is our inverse. Notice that is exactly the same as we got using the other method. The final part of this review worksheet is determinants, which we have spent a lot of time doing. Okay, and honestly, all we need to know how to find like a determinant of a 2 by 2 and how to find a determinant of a 3 by 3, which we practiced using Kramer's rule. So you guys, key things on this test, I need to make sure I know how to use each different type of solving. So there was a lot of them. Okay, continue to practice and practice and practice. Check your answers. My hope is that this is a great test for all of you guys.